Hello, this is Mahant and I'm going to be showing you my data science project. So this is my data science report that I've created right over here. This was a project that I did during my summer last year for the IBM data science course, and this covered a lot of the fundamental data science concepts and techniques and also the mathematics behind data science. I was also particularly interested in it because I'm usually interested in statistics and mathematics, and I was able to put my knowledge to use by taking this course. And I also got a certificate after this course for completion. So I'm going to be clicking on code and then copying the URL, then opening my command prompt or terminal, whatever you call it, and then pasting my URL. I'm going to change my directory to the data science. Then I'm going to open Visual Studio Code to view my code. As you can see my code right over here. I have created multiple programs which were not required by the course, but for my own interest and for learning data science, this was essential. So one algorithm I'm going to be taking a look at today is the k nearest neighbors algorithm. So what this algorithm does is that it takes one unknown point as I was talking from a visual perspective, it takes one data point and there are multiple data points around it, and you're trying to find the closest k data points to this unknown data point. And classifying this unknown data point by finding the classification of these data points and averaging the results of that. As you can see, the k value here would be 1, 2, 3, 4, 5, and 6 within this radius of 3, because this would be the total number of data points surrounding this unknown data point. And the classification would be towards the blue data point because there are 4 blue data points compared to 2 green data points. And therefore, this can also be considered as the same category as the blue data points. So that being said, I'm going to be going back to my code editor and demonstrating this algorithm. So what this method does is that it calculates distance between 2 points x and y by iterating through the list and applying the Minkowski distance formula to calculate the distance between them. Later, I'm using this method, which is called distance, in this KNN algorithm by finding the distance between these data points, as you can see here, this unknown and point. And then I'm sorting the distances. As you can see, it's sorting the list. And I sort them in the ascending order because I want to find the nearest data points through this data point. And I return the k data points that are closest to this data point, which would be nothing but their coordinates. But to implement the classification of those data points, I'm using a package called sklearn. But as you can see, it is just an algorithm right here. So I'm just implementing the mathematical part of the algorithm. I'm going to add a snippet of code called underscore underscore name equals underscore underscore main to run this program at all times if the file name is knn.py. I'm going to create a list of data points for testing purposes. As you can see here, I have created 4 data points, which are nothing but 4 tuples of numbers in the 4-dimensional real coordinate space. And if I am trying to find the distance between them and the unknown data point, which I will create right now. Let me make it 4, 4, 2, and 3. If you're wondering where these coordinates come from, they are just arbitrary data points in the real coordinate space, so you don't need to worry about that. You could give any number of values, extending up until 1, extending from 1 up until the n-dimensional real coordinate space. And you can set the k value, which is nothing but k data points to 2. But if you want, you could also set this to any value, just like these data points. So now what this is going to do is, it's going to take the list, it's going to iterate through the list for each element and find the distance between this data point and this data point, this data point and this data point, and it continues on until the nth index of the list, and tries to sort the list of the distances and finds the k nearest neighbors, which is 2 points right here. So it will find the two closest point to the unknown point from this list and return those data points. So I'm going to be opening terminal to run this program. For CD into algorithms, because that's where the KNN program is located, and run the KNN.py. As you can see, the numbers or the tuple of numbers written right here is reasonable, because 3456 is reasonably closer to 4423, and 5432 is reasonably closer to 4423, while the other points seem distant. So this allows for classification of unknown data points, and is a very useful data science technique. But the most important of my projects, or sub-project as you may call it, would be my COVID-19 project. So I'm going to go into projects and model.py. As you can see, this is the COVID-19 project, and I have a data set of the values. The columns in this data set would be the day, the number of cases, the number of deaths, and the number of cases per 100,000. And I have modeled all of the relationship between the variables and how did the values have increased over time. So for your information, these cases begin with January 1st up until 123 days after January 1st. And these values represent the columns shown above. So for example, if I take the first row, then the first day would then day 1, and there's going to be 823 cases, and there are 12 deaths, and the total number of cases per 100,000 would be 1.11, which is just the ratio of the total cases divided by the number of divided by the denominator, which is 100,000. Now I'm going to be running my model program, which will demonstrate the graph of my model. As you can see, it created a model of the COVID-19 cases, starting from 823 cases, which represents 0 in this dataset. So I forgot to mention that in data science, cases are usually normalized, and when data is normalized, you are unable to retain the original data points. So therefore, you use normalized values. In the scale, 0 represents 823 cases, and 1 represents 67,717 cases, which is just the number right here, as you can see. 67,717 and 823. So what this does is that SciPy, or this package right over here, fits a curve through the data points, finding the best curve coordinates for best curve coefficients for this model. As you can see, in this case, the model shows a cubic trend, which means that the cases have slowly increased over time, slowly slowed down, and now it has started increasing. And by now it must have slowed down. So that would be an example of a logistic growth, but from January 1st up until when I created the project, it showed a cubic trend. The other model that I created was the plot.py model. This model is another matplotlib graph that shows the relationship between the time in days and the number of cases. As you can see, this is the total number of cases in USA, while the second graph is about the number of COVID cases per 10,000. And both of them show a cubic trend, which means that none of them have changed except for the values of the graph. As you can see, it has been divided by 100,000, but here it is the not normalized values, which is just the actual values of cases that have increased over time. So this helped me see the relationship between data science and real life, and also predict trends in different cases, such as in this case it appears to be COVID-19, and these models can help people better predict pandemics and other diseases, and also try to take preventive measures against them. I'm going to be looking at another project, which is my final project for this course. But before that, I'm going to be covering another model of China, but this time it's the GDP. So I'm going to see into my nonlinear regression directory. A nonlinear regression function is any function that is not a linear function. It can be a quadratic function, it can be a cubic function, it can be any type of function except a linear function. And sometimes it can also be an exponential function, a sine function, or a logistic function. In this case, this curve can be modeled by a logistic function. As you can see, it's a sigmoid function, which has two values, beta 1 and beta 2. And you're exponentiating this model. And this will be the curve of the dataset. Yes, I'm going to create a new window. And I'm going to go to Desmos, which is a graphing tool. And I'm going to show the graph of the sigmoid function. 1 by 1 plus e to the negative x. This curve is a characteristic curve that helps determine probability in cases, and it shows slow growth. Especially in data science models or in any other cases such as evolution, biology, or in exponential trends, the growth never tends to be completely exponential as it tends to slow down after some time. The sigmoid function is the best function that resembles the exponential function as it has an e value as a base, but as it closely approaches 1, the e value starts getting closer to 1, and therefore the model plateaus out, as you can see here. I'm going to graph e to the x in comparison to this model. As you can see, e to the x approaches infinity as x approaches infinity, but the sigmoid function shows realistic growth, which can be applied to realistic models, while the exponential function cannot. So this is the power of the sigmoid function, although it seems more complicated in this case. So I'm going to be going back to my code editor and running this program to show how it looks like. As you can see, this would be the curve right here. It shows an exponential growth from 1995 up until 2000, but later it tends to plateau out as the GDP starts to as the increase in GDP starts to be slower than before. This makes sense as at start any country or any type of growth tends to be faster, but over time its potential to grow even more tends to slow down. So therefore it shows a plateau in the graph, and that's what this graph shows right over here. And it shows the GDP in tens of trillion USD. So here it's point 0.8, which means point 0.8 into 10, which means 8 trillion USD at this point right over here. So this was an interesting exercise because I was able to model real life situations using data science and make sense out of it. Without learning data science, I wouldn't have been exposed to these kinds of things, and I wouldn't have learned the applications of topics that I'm learning in school or outside of school. So that's it. So that's it for today, and have a great day.